everybody, and welcome to this video on functions. In this video, we have a look at the inverse of a parabola. Now, if you recall, this is how a parabola looks, and what we have is that the parabola is a many-to-one function. What we mean by a many-to-one function, for any particular y value, there are two associated x values, making it a many-to-one function. So what happens is now when we have to find the inverse, which is the deflection about the line y is equal to x, the inverse looks like this, and what we have is that the inverse is no longer a function. So what does that mean? That for one x value, there's two associated y values, which means that this relation is no longer a function. If you are confused with the many-to-one function and definition of what's not a function, please watch our previous videos on the introduction to functions to understand these terms. So we have that the inverse of a parabola is a many-to-one function, which results in the inverse not being a function. So how do we fix this when we get the domain? The solution is quite simple. We have to restrict the domain. What does that mean? That means cutting our original parabola in half. And what line do we have it? We cut it in half. We cut it in half on the axis of symmetry. So for this graph over here, we can have two options. We can take the negative part of the parabola, and then the inverse now is a function, as if we had to do a vertical line test. It cuts at each place only once, and that would be if we took the one half. Or we could have taken the second half, so from the axis of symmetry to the positive infinity, and then that resulting inverse is a function. So what is in dotted lines over here is no longer part of our graph. So the full parabola, we're not taking it, we are taking half only. So we're cutting out, that's cutting out the whole bit. We're cutting out the bit that is just part, so we're cutting out the bit that's repeated. And what happens is then we have an inverse, which is a function. So the inverse of this negative piece is this over here, or we could take the positive piece, which is this piece over here, and the inverse would then be what we have over here. Okay, so that is quite important, and it's a very important point for you to notice that when we are working with a parabola, the inverse is not a function. So we have to choose to either work with the positive half of the parabola or the negative part of the parabola, and then the domain will either be x is an element from minus infinity to p if we are dealing with the negative values, or x is an element from p star to infinity. And again, what is p star? It is the x coordinate of our axis of symmetry or turning point. It's the x coordinate of turning point or axis of symmetry. If you are unfamiliar with these terms, please watch our previous videos on the parabola. So let us have a look at an example. So over here we have f of x is equal to x squared minus 4. What we're going to do is we're going to plot this graph, and then we're going to find its inverse and plot the inverse. So here we have, to get our x-intercepts, we make y equals 0. So we have 0 is equal to x squared minus 4. And then this here is a difference of 2 squares, so we can factorize it. And we get x is equal to 2, or x is equal to negative 2. So this is 2 and 0, and negative 2 and 0 is our x-intercepts. To get our y-intercepts, we make x equals 0. So our y-intercept is 0 squared minus 4, which is just minus 4. So our y-intercept is minus 4. The other thing that's quite important about the parabola is the axis of symmetry. So the axis of symmetry, the equation is x is equal to minus b over 2a, where b is the coefficient of x and 2a is the coefficient of x squared. The coefficient of x, there is no x term, which means it's 0 over 2 times 1, which is 0. So this here is x is equal to 0. And to find the corresponding turning, so the x coordinate of your turning point is 0. To find the y coordinate, we substitute x is equal to 0 into the original equation. So we get y is 0 squared minus 4. So the 0 and minus 4 is also the turning point, and the axis of symmetry is x is equal to 0. Please note that the x coordinate gives us the x coordinate of our turning point gives us the axis of symmetry. So I think that is enough information to plot our graph. So let's put in our axes. And then we're going to plot our graph. So our x-intercept is 2 and minus 2. And our y-intercept is negative 4. I think this one I drew a bit too far out. Let's move it a bit more in. Like there. And then minus 4. Its shape is the positive parabola. The turning point is also 0 and minus 4. So the y-intercept is also the turning point. So then if we draw our graph, it will go, oops, that's not a good start. Okay, let's pretend that looks pretty symmetrical. Okay, and our axis of symmetry is the x coordinate of our turning point, which is x is equal to 0, which is the y-axis. Okay, now we would like to get our inverse. So the inverse, again, just remind you, is we swap x and y and solve for y. So we have, this is y is equal to x squared minus 4. So we can have x is equal to y squared minus 4. Take the 4 over, y plus 4 is equal to y squared. And when we square root, we get two answers, plus or minus x plus 4 is equal to y squared. Now, what I said earlier is that we cannot get the inverse of the full function because the full function is not, the inverse of the parabola is not a function. So we're going to choose half to work with. I'm going to work with the positive half, so I'm going to remove this half. So I'm restricting my domain. Okay, so I've chopped my graph in half, and my domain that I'm working with is x is an element from minus infinity until 0, which is our x coordinate of our turning point. So there, I've cut my graph in half. Now, there's two options for this y. There's two options for this y, plus or minus. We're taking the negative half, so our inverse is minus x plus 4. If we took the positive half, then we're going to take plus x plus 4. Remember, whenever you square root, you get a plus and minus. So now we're taking the negative part, which is minus. So to plot our inverse, we swap whatever belongs to x and y. So the y-intercept was minus 4. Now the x-intercept will be minus 4. And the x-intercept was minus 2. Now the y-intercept will be minus 2. Sorry, it is starting to storm if you hear thunder in the background. Okay, and then if we then draw the positive half, we get that. If you've drawn it correctly, you would find that your graph should be symmetrical about the line y is equal to x. So that's the line y is equal to x. And you can see now the graph is symmetrical. So that is a perfect example of the inverse of a hyperbola. Let's quickly end off with the domain and range of each of them. So the domain of our parabola, remember now we cut it in half. So it's x is an element from minus infinity to 0. Our range of our parabola goes from the minimum to infinity. And it goes through that point. And our our domain and range of our inverse, our domain of our inverse, the x values it takes is -4 to infinity, and our range is x is an element from -infinity to 0. Sorry, let's put square brackets here because it will actually go through 0. Okay, what can you notice? And it's a very important thing to notice, is what used to be the domain for f now corresponds to the range of f inverse, and what used to be the range for f now corresponds to the domain for f inverse. If you have found this video challenging, please re-watch the series on the parabola and make sure you understand the properties of the original parabola before trying to understand the inverse. If it helps, please watch it again. If you have understood it, please watch the rest of our series on inverse functions.